could you? And I started working on that. So anyway, I'm involved in all this stuff. And then I finally had a TV repair that I had about 50 people working for me. And like I said, I collected a lot of this stuff. And I just love it, you know, so I've watched a lot of these meetings in, you know, but I haven't really, this is the first one I've actually live participated in. So I like what you're doing, and I, you know, like to support it. And that's all I got to say.
Okay. Thank you, Kendall. Is there anybody else?
I'm Dennis Nishler, and I want to join the meeting.
Hi, Dennis.
Hi.
You want to say a little bit about yourself?
I'm an old TV technician from way back, and now I collect old TVs and fix them, and old radios. And I'm really impressed by the TV museum, all the beautiful stuff that they have. And I just wanted to someday come by and look at your TVs, because I look at them all the time online, and I wish I had some. But this is all I got right now, besides a couple in the living room. Thanks for letting me join.
Oh, well, thank you for joining.
Hi, this is Bob out in Northern California. Dad was a Philco engineer back in the 40s and 50s, turned manager when he came out west to Philco up on WDL. Left me with a lot of legacy about Philco products, and just generally made me a collector. I got a little carried away. Some of the stuff found eBay and started buying. So now I have about a 1,300 square foot loft up here above a 1,700 foot garage. That is my hobby space, and try to keep things working when I can. You know, too many projects and not enough time on them, but I've got my share of Predictas and a couple of Safaris. Recently got a Philco console, 1967 hybrid Roundy, as they call them. I had another CRT for it, 21 FBP 22. Was able to get that going, but now the high voltage went down the other day. It started shutting down the horizontal, and I think it may be one of the thermistors underneath. It was like there's a couple of thermistors under there, and if one of those was letting go, so I got to pull the chassis. Lifelong electronics addict, also motorcycles, old cars. Too many hobbies, not too much property.
Great, thank you. Anybody else? Okay, well, welcome everybody. We're now going to look at a couple of items in the museum, and this month I have picked monoscopes as the subject. We have two of them, can you get Larry's video up? Looks good. Hey Larry, how you doing?
I'm doing all right, Steve.
Good. Okay, we're going to start with this thing. This is a Monoscope program source from 1946. And it's got sort of an interesting story. Bob Dobush travels around the Midwest and the East Coast looking for, he's a tube dealer basically, and so he's always looking for things, and he's on the board of the museum, so he's always looking for stuff for us. And he was in Buffalo, New York, and somebody told him about this weird thing on the 4th floor of a warehouse building in the old decrepit area of Buffalo. So he went to look at it, and discovered that it was a monoscope. And the reasons for its existence is that it was built by ARI, American Radio Institute, which was a training school, both correspondence and in person, that existed at least going back to 1939, maybe earlier. They were headquartered in New York, but they had branches in Buffalo, and I think in Syracuse and Rochester, and maybe Albany. Now, New York City and Albany had television stations in 1946. The other cities didn't. And so they built, we think, 3 of these so that they could start training GIs coming back in television repair. Obviously, these cities didn't have TV stations. There wasn't much they could do. So they built these things for that purpose. This one has 155 tubes in it. Can you wheel it around, Larry, and open up?
I tried earlier. It won't budge at the moment.
Give it another try. It's probably stuck to the floor.
All right.
There you go. Perfect. We got this several years ago, and that was back in the days where I was restoring everything I could get my hands on. And so I decided to take it and make an attempt at restoring it. And I don't remember a lot about it, and we didn't document it. That was one of the earliest things that we restored. You can see straight ahead of you that the chassis that is at an angle, that's the video preamplifier. On the left, I believe, is the, well, maybe on the right is the sweep circuits. I think that's video processing. Move over to the right. Can't remember which is which, but anyway, it has in it a countdown sync generator. And it also has a channel 3 modulator. Yeah, there's the horizontal output transformer, you can see, and the high voltage rectifier for the monoscope tube. So it was, and there's the back of the CRT for the monitor. It has a complete monitor with a 10 BP4 tube in it. As you can imagine, this thing was a nightmare to restore. We got it working. And if you look on our website, you'll see, yeah, there's more parts everywhere, more tubes. It's a complete monster. We haven't fired it up in years, but it did work. It uses the 2F21 monoscope tube that RCA started making about 1946 and made it for many, many years. It was used in television stations, and you could get it in 2 versions. You could get it with a generic Indian head test pattern, or you could get it with a custom pattern in it. When we go over and look at the other, why don't you flip it back around, Larry, and let's look at the front of it. You can do it. And the top, what you see at the top is a cooling fan, by the way. You can imagine with 155 tubes that it generated a lot of heat. Zoom in on the thing at the top, Larry, on the front top. That is the monoscope tube, not that. That's the cooling fan.
Oh, sorry.
But go down, go up. Keep going. There you go. Okay, there's the monoscope tube. You can see the deflection yoke. There, the tube is in there. That's the deflection yoke, which is off of a TRK-12, which I thought was interesting. There's the socket for it. And the inside that box, there you go. There is the top of the tube. It has the cover removed. And you can see there's the video output, and that is the plate that has the, and I think that's a generic 2F21 that was in there. Because when we fired it up, that's the pattern that that appeared. Okay, now go down lower, Larry, on the front. There is the waveform monitor. And it's I think a 3KP1, something like that. And you can see these are all hand lettered. And if I remember, this is serial number 2. There's a serial number on the back. And I'm not sure how we learned that 3 of them have been made. I think that Bob talked to somebody that was involved with it and got that information. But we think this is serial number 2 of 3. All you can see it's got the sync could either be 60 hertz in locked or internal sync from the countdown sync generator. Now going down that lower, Larry. Now this is the video monitor. As I mentioned, it's a 10 BP4, and it has all the circuitry for driving it. Any questions about this monster?
So its sole purpose was to create a test pattern?
So that they'd have a channel 3 signal for students to be able to learn how to repair TV sets. I don't know how many students they had, probably quite a few. I know we have the picture of their New York operation right after the war. And they had a room with, maybe 100 people sitting there with TV sets on the bench to repair. So that's its only purpose. And of course, I can't remember when stations came on the air in Buffalo, probably 1948 would be my guess. But for a couple of years, that was the only way they could get an RF signal with video. Any more questions? Well, then let's move on. Go ahead.
About how much does that thing weigh?
What do you think, Larry?
Too much.
A couple 100 pounds, I would think, at least. It's the reason it was so hard to move is that we have an asphalt floor in there, and I think the weight of it and it's got roller wheels on the bottom, and I think they sank into the asphalt.
Any idea what the power consumption is on it?
Can't remember, but I think it runs off of a 20 amp circuit, 110 volts.
Thank you.
Probably uses every bit of that.
I see all those controls for the waveform monitor and the video monitor, but how about the operation of the monoscope itself?
They were all internal. None of them were brought out to the front. I don't believe. These are all. Well, here's some. But these are just video controls for gamma and blanking and video. The monoscope really. There's a bias and a focus adjustments, which were. On the back. I guess apparently they didn't need to get to them very often. And it looks like since this scope has a range switch on it, it looked like it was also made as a general purpose scope, so you could use it for maybe troubleshooting this unit. I don't know. Any more questions?
What was the year? If I may have missed that.
46.
Is the monoscope sort of a imaging tube?
It is. It has an electron gun in the bottom and a deflection yoke that scans the electron beam over a plate, a metal plate that's etched with the image. And then there's a collector that collects, I guess, reflected energy from as it scans across, and that's the video output.
So that metal plate is sort of a target with it, like a
Sort of a
chemical
target.
etching on it, or
Yep.
what is that? What it is?
Yep. Yep.
Oh, so it affects how the beam is reflected
Yep.
to the. Oh, I see. Okay. Is it high resolution etching or coarse?
It's pretty. I don't know. It's pretty. I mean, the resolution of these things is high because they use them for the later application of the 2F21 was for TV stations. They were the go-to gadget for checking the performance of all the studio and transmitting equipment. And so they produced a pattern that had resolution, I think, about 600 lines. And they were used for setting up linearity and frequency response and everything else for everything in the studio and the transmitter.
Oh, so technically it wasn't an imaging tube other than the fixed image that it has internally?
Yes, that's right. That's right.
Now, what difference did its resolution make if it was 600 lines? Wasn't it, I don't know, 520? I can't remember what the standard.
Well, TV stations all, even though they're limited by the channel width to the number of horizontal lines of resolution that they could transmit, they wanted their signal to be well above that.
Oh.
So that there was no loss of fidelity in their equipment. So all the broadcast equipment, the cameras and video amplifiers and so forth, were designed to have a resolution above the 400 and some lines that you could get in an NTSC channel width.
Was that true for color as well, or was this the standard that went on for decades, that black and white was, like in the 50s? It's maybe 525 lines or something. I don't remember.
Well, the picture in both the color and black and white system is made up of 525 horizontal lines, and the vertical resolution, the number of lines you can resolve of vertical lines, with black and white was limited just by the bandwidth of the channel. In color, it's very complicated. Different in order to cram all that video information into what was a black and white channel, they had to make compromises on the resolution of different colors and so forth. So it's the color resolution was actually probably less than the black and white resolution.
Now, did you say this one? I don't want to hog this. Is that 441 lines? Or is it, how many lines is that thing?
Okay, it's 525 horizontal lines. That was the standard that was transmitted starting in 1941 and continued all the way through the digital age, beginning of the digital age.
2009.
2009, right. So that was the standard for 525 lines, double interlaced, and then, as I mentioned, the vertical resolution of the vertical lines was less than that.
But remember, that doesn't include the, shall we say, invisible, part of the picture in the vertical blanking interval.
Yeah, right.
Is that the interlacing? The vertical blanking interval? Is that the interlacing?
Well, that's the period in the picture where the scanning has finished of one field of television, and the scanning beam returns to the upper left-hand corner and starts the process over again. And that happens in the vertical blanking interval. Now, interlace does occur there by timing pulses.
Okay.
Yeah, you effectively had 480 visible lines in the NTSC image, just like you essentially had 576 lines visible in the old-fashioned PAL and CCAM images.
Any more comments, questions about this machine? Well, then let's move over to the more modern version. This is the Rca Tk1. Now this was, was using it. They probably use these things through the 80s, I would think. Does anybody know the answer to that? This uses we're using a modern. This was donated to us from Channel 10, the CBS affiliate, and in Columbus, and it came with a custom tube. There at the top, you can see the monoscope, a good picture of the monoscope tube. And there's the video output. And on the side of the tube is the anode connection right there where its high voltage was applied.
Was the video output the beam current?
Well, it wasn't directly the beam current. It was an extremely low level video signal that had to go into a preamplifier. Now we have a modern sync generator for this unit. It doesn't have one built in it. And there it is right there. And then go down below, Larry. There is the unit itself. And you can see there's the Monoscope Assembly. And I guess it was used at least in 1967 because that's what the label says on it. We didn't do much to this. We just fired it up. I think you could see a few capacitors that have been replaced. But there's the filament lighting on it. And there are the controls for the monoscope. And they are, things like width, height, centering, gain, focus, beam current, brightness, vertical centering. Now this thing takes a little while to warm up.
So could that be construed as a calibration device for a station?
Exactly. That's the power supply, the RCA power supply that works with it. Go back up to the, and that at the bottom, I think we just left it in there to fill space on the rack. It has nothing to do with it. Let's go back up to the picture now and see if it's come in so that it's decent. Yes, CBS television network, Hollywood. That's a different monoscope. The one on the top is the one for WBNS. I don't know who donated this. That one has the WBNS channel 10 pattern, and this was donated to us by somebody, and it was obviously used in Hollywood and at the CBS studios.
Even after color transmissions were available, was this still used to calibrate? Was the black and white signal sort of used as the calibration standard as station? Or was there a color version of this unit?
There was not a color version that I know of, and I'm not sure when. I'm sure this was used well into the color era.
Okay.
I don't know when it was replaced. Can anybody answer that?
In somewhere in the 80s, a Japanese company started to produce digital monoscope generators. And of course, what that did is it got rid of all the tubes And also it got rid of any possibility of the size or linearity drifting or anything like that. But they first came out when it just barely became possible to do it digitally. So they were fairly expensive, but they had the advantage of being completely stable.
Now, of course, you could get, we have a pattern generator that generates this pattern and 24 others. It's the size, about the size of a pencil. I think it cost $50 or something.
It's got a video output then, or what?
Got a video on one end of it. It's got a BNC connector, and on the other end, it's got a power supply input, and it's got a little push button on it to cycle through the different test patterns. And that's what we use for aligning our equipment. I'm sure there are plenty of other versions of the same thing.
Yeah, one thing to know about the Monoscope is it really has no grayscale capability.
Really?
So in the pattern where you see different gray levels, if you look closely, you see that they're made up of dark black and white lines of varying width. So the pattern on the tube is actually finer than the resolution wedges that you see there.
Any more questions or comments?
So there's no gray levels in that image?
Well, there are. I mean, if you look at the image, you see gradations of gray.
The tube has no gray level capability. Is that what I heard?
Correct.
No, that's not correct. It's
Yeah,
fully, it's fully grayscale capable.
Oh, it is. Okay. So can you actually, if you looked at that etched image, see it by eye?
You can.
Huh.
Yep.
Well, the etched image is on the inside of the tube.
Right.
Yeah.
You'd
You
have
can
to-
look through the edge of it.
Yeah, you'd have to
and-
destroy the tube to actually look at the pattern, to start the target.
No, you can see it through the edge of the tube.
Yeah.
Not well.
It's really good. So the composite color must have been really good that you could calibrate with black and white and still get the color imagery out, I would think.
Well, there were other instruments used for the colors, like a Vectorscope, for instance.
Oh, okay. So this is
a very handy. This is a very handy product to have in a station for many, many years. And
Yeah.
basically, they used them until the tube lost emission.
Yeah, and a lot of stations ran them overnight. You know, when they went off the air at 1 in the morning, they ran them all night till the programming started in the morning. And that allowed people at home to adjust the linearity of their TV sets.
So those test patterns back then were generated by one of these?
Yeah.
Oh my goodness.
Yeah, the TV engineering books always had long sections on how to interpret defects in the signal by looking at different parts of the test pattern.
1, 2.
Hey, Steve,
Yeah.
Steve, James O'Neill here. Can you
James.
hear me?
I can.
I don't have any side tone. I can't hear myself, so I'm not sure. Yeah, I'd like to add a little bit of information about the Monoscope.
Yeah, you could do the same thing by putting an art card in front of a studio camera and lighting it. But of course, this was very costly in early television because sitting there on a stationary pattern, first of all, you had a burn-in with your image orthicon. And secondly, you carved a lot of life out of an image orthicon, so you didn't want to do this. So this is one of the reasons that television stations almost universally had a monoscope camera to produce his video signal when nothing else was happening, when there was nothing coming down the network before the stations went on the air, either in the morning or where I grew up, there was no network connection for a long time. So the station would sign on about 2 o'clock in the afternoon and sit on the monoscope pattern with some tone or some music until programming started maybe 4:30, 5 o'clock. And this was because the station was trying to assist the growth of television. These furniture stores, appliance stores were selling television sets, and obviously the installation people needed a source of a signal so they could set the set up, adjust the antenna, and show the customer it worked. So this was a very big thing. I remember sitting there and watching the monoscope, the Indian head monoscope pattern, just fascinated, listening to some of the music they played under it till program started later in the afternoon. And when I went to work in Washington, we had a monoscope in operation. That was 1975. And we kept the thing in operation. Didn't use it a lot, but it was nice for setting linearity on monitors in the shop where I was. This thing operated well into the 1980s, but of course the death knell of the monoscope camera was color. And everybody that adopted color, of course, had a color bar generator, and it was very easy to just put color bars up when you didn't have anything else happening. Of course, they didn't really give you a linearity, but again, if you wanted to set linearity on something, you had a crosshatch or a dot pattern you could use for that. So eventually, the monoscope went into oblivion. Now, I do recall into the 80s, there was a Japanese company. I cannot think of the name of the company, but they made a solid state version of the monoscope. The pattern was very much like the Indian head test pattern, but instead of having the Native American there with his feathered headdress at the top of the picture, there was a dragon. It came from Japan. Apparently, they really didn't have any connection, really couldn't relate to the Native American there with his headdress. So yeah, the monoscope, again, the one that we had, again, perpetuated well into the early 1980s till everything was fully color and we just sort of forgot about it and switched it off.
James, that was Shibasoku.
Yes, okay, got it. Yeah, I couldn't think of the name, but you're
Yeah,
exactly right.
thank you.
What does linearity mean in this context?
Linear, you want me to answer that? Yeah, linearity, we're adjusting scans either in a camera or monitor, and you want a nice linear scan so the picture's not bunched up at the top or the bottom or on the left side or the right side. So the monoscope provided a nice circle, and if the circle was a nice round circle, you knew your scans were linear.
Got it. Okay.
Hey James, this is Dave.
Yes.
I'm shocked that stations would use a camera on an art card. It just seems like it could introduce so many variables. You've got your geometry between, getting the camera perpendicular to the card. You get any distortion the camera introduces. You got the levels. It just seems like there would be so many opportunities for the standard to not be so standard if you weren't using the monoscope.
Well, that was the whole thing about setting a camera up on an art card. Ideally the Indian head test pattern there with the linearity circles. I mean the circles for establishing vertical and horizontal linearity. I mean that's what you had to do with a black and white camera, and to some degree a color camera. Even though they were, the color cameras I used, they were solid state, a lot more stable. But of course, when you fired up, you did put the camera on charts, and you sat there and tweaked till you had very good horizontal, very good linearity before you put the thing on air. And I've got some laugh-in recordings, Rowan and Martin's laugh-in from the late 60s, I guess into the early 70s when the show ended. And they're using TK41s out in Burbank. And several of the shows, one of the 41s is not adjusted really well. And you can see compression, non-linearity on the left side of the picture. That camera really stands out. Somebody apparently didn't have time to set the camera up properly, or maybe something started to go west once they started taping the show. But no, you put the camera on charts, probably 30 minutes, maybe an hour before you started the show, just so the engineer had time to do the tweaks on the camera to get the grayscale tracking right, setting beam current, all the parameters there with an image orthicon or even a Vidicon. But, a linearity was very, very important because if something moved, especially the camera moved left to right, and you had compression on the left side or right side, non-linear sweeps, it really stuck out. It really did not look good. So you spent a lot of time, adjusting the camera, trying to get the best performance out of it you could. And you did use, you use a studio chart there. So the cameras did look the same.
Yeah, I have one of those charts, so I guess that did happen. But I could just imagine on a bad day, they don't get the camera adjusted quite right. And now your poor TV service guy, he's using that as the standard to set up the sets in his showroom. I can see that happening. I don't know whether it did or not.
Yeah, always better to go with something the network is sending down, if in doubt. But the stations were pretty good, and I'd say the Indian head monoscope test pattern was just people my age, it was a standard part of television early in the broadcast day before the station started programming. This thing was on the air early, or if the station wanted to stay on after normal sign off and maybe do some work at the transmitter, this is what they put up and fed on the microwave or fed the coax out to the transmitter. So the transmitter guy had something to work with there at the transmitter site.
Hey, Jim.
It was just a go-to signal source. It didn't require any preparation. You turned the monoscope on, you had your 1 volt peak-to-peak video, and everything was good.
Hey, Jim. How co-located
Yes.
was the audio generator to generate that 1 kilocycle tone back in the day? I mean, was it close by to the monoscope?
No, it was right. Probably a test oscillator there. I'm sure it went through the switcher in master control in most stations, or the small audio console, which might have been there. Most stations use some sort of an audio follow video switching. So when you change the video source, the audio moved with it. But you had, I'm sure, had a test position there on the switcher for the monoscope, and you were getting a split from a distribution amplifier in the rack somewhere back in the bowels of the station, the equipment room where the test generator was located. It would not, it was a very small station, everything probably in one room, but larger stations that you had a test generator back in the rack room and the equipment room, for where everything else went. You really didn't need that up in front. Again, it was one of those things that just sort of ran forever. You didn't need to do a lot of adjusting, a lot of maintenance on an audio oscillator making a 1 kilohertz sine wave.
Steve,
Thank you.
How was
Steve?
that?
Yes.
on that monoscope that Larry is focused on, it had a sticker on the cylindrical part on the left there that said Columbus Dispatch, which would indicate that it did come from WBNS in Columbus, because Dispatch, the newspaper, used to own that TV station.
That's correct. Yeah, WBNS stood for Banks, Newspapers, and Stations. And it was the Wolf family who were prominent in Columbus business for many, many years.
But somehow the engraving of the CBS Hollywood got onto that thing.
Well, no, as I mentioned, we changed.
Oh, you changed it out.
Interesting. The one that's on the top that Larry showed you was from was the one that has the WBNS.
Okay.
Has an Indian head and WBNS on it.
Okay. So the tube that's in there now is from CBS Hollywood And the
Yes.
device is from WBNS Columbus.
Exactly. Right.
I interned for a
can
semester
I-
at the Mike Douglas show in Philadelphia. It took them, they had TK42 43s there, which were terrible, terrible cameras, very noisy, terrible color. But it would take the engineer 1 hour minimum per camera for the 3 cameras before the show each day to set that up. And it was a struggle.
How was the
Hey, Steve, can
monoscope?
I pop in with one other little bit of trivia here?
Absolutely.
Yeah, I want to talk to the Monoscope was RCA's. I'm assuming it was trademark name for this particular tube, basically a cathode ray tube with this plate in what would be the phosphor area of the tube that was scanned with this particular pattern on it, which could be customized or RCA standard Indian head test pattern. 2 other companies that I know of made a similar tube. One was National Union. They called theirs a monotron, and Dumont made one. Really strange name for it. It's called a phasmajector. Maybe you've run across those.
Yep.
And I have a theory. I've never seen this in print, never seen anything about this, why RCA used the Indian head. But I do have a theory about maybe why they adopted this back in the early part of television. I guess I wish we had some more information on from Chuck Ferris, since he has the original artwork, the Indian head test pattern artwork for the date. I don't recall the date. I did a story on this some years ago. I went down to Chuck's place in Turtletown, Tennessee, and he showed me the original artwork that he had been able to purchase from an eBay dealer that had the Indian head and also had the concentric circles which had been laid down. But one of the things, if I can mention here, why the Indian head was used, I think this was probably because RCA wanted something that didn't look strictly engineering, strictly something a physics lab. So they wanted something humanoid, a humanoid figure associated with this pattern, because people would be seeing it on their television sets before programming started. And I got this idea. I was in the Smithsonian. I had privileges, go in the back room sometime and look at some of the artifacts which are never put on display. And they had just acquired some Dumont phasmajectors. And these things were made back in the 30s, 40s. And you look through the tube, as you say, you can see the plate in there, the signal plate with the picture on it through the side of the tube. And I looked in there and you saw some Hollywood film stars and some models. And immediately it became evident to me why RCA, with their divine wisdom, chose the Native American. You look at these things, 1930s, 1940s hairstyles, clothing, they look so dated, so out of place in the 1980s, I guess, when I saw these things. And you think about it, our hairstyles change, our clothing styles change every few years. So if RCA, the television stations, were going to keep up, they would have to make a new test pattern every few years with a humanoid there, a human, with a current hairstyle, the current dress, whatever. But the Native American and his headdress, that never changes. That's sort of something that goes on and on and on and on. So that's my theory about why the Indian head was adopted. Again, I've never seen anything printed, never seen anything written about this. Nobody at RCA ever told me this, but it just stands to reason it was an economic thing. So you wouldn't have to make a new run of these tubes every few years just to keep up with the hairstyles in the current dress.
Well, there's a whole article on it on Wikipedia, and it dates from 1939.
Was it similar to an Indian head penny?
Oh yeah, it's the same thing. And
Oh.
they have a beautiful rendition of it if you want to make your own. I did, and I put a grayscale on it and the color bars on it, which I use for my own camera when I'm setting it up.
Looks like the coin.
Well, I don't know what you mean. Looks like the coin. You mean the Indian head nickel?
Penny, yeah, or penny. I know they had Indian heads on them. I don't know how long. ago it was.
Not sure.
Hmm.
I'm not clever enough with Zoom to put up the image, but I've got it on my storage thing.
Well, I was curious about the monoscope thing itself. How did that get maintained? There's a lot of vacuum tubes in there and so on. Did someone periodically have to test them all, or how did they know that it was functioning properly or maintain a equilibrium state of its functionality? That's a lot of tubes in there.
Well, you know, everything in a
Can
TV.
I hold up my hand again? This is James.
Yeah.
Yeah, this is James. Yeah, I started working. We had no television in my town. I started working in small town radio when I was not quite 14 years old. And one day, one of the older people at the station, we both had the same day off, decided to make a trip to the big city where there was television. That was Shreveport, Louisiana. And we toured all three of the stations there. And I'll never forget this. It was the ABC affiliate that was KTBS. And we were walking around there. A lot of the stuff was tube. Again, this was in the early 60s, early mid 60s, this time frame when I was in high school. And again, the transistor had not really taken over. There was a lot of tubes in all of these stations. But in this particular station, there was a small grocery shopping cart. And there was a tube tester mounted between the handlebars on the shopping cart. And the shopping cart was filled with new tubes, new in-box tubes. And I asked about this, and the person giving the tour said, yes, we have one person, his entire job is to go around and test every tube in the studio here during the course of the week and all of the equipment and replace as necessary. Now, this was a fairly small station. I think they had maybe 2 cameras. There was no color. They did have some videotape, but that was it. It was a small station. And this figure it stuck with me all these years. He said on a given week, the station spends about $500 in tube costs, just replacing the tubes to keep us clean, keep us with a good looking signal on the air. So yeah, you spent a lot of time testing and changing out tubes. Keep good video going at your television station and good audio too. So one of the reasons I was so glad when I got into television, making a living at it, we had moved fairly far into solid state and we didn't spend a lot of time changing tubes. That's not to say that, some of the gear I worked with when I began working full time in broadcast television in 1969 was not tubed, but we were getting very much into solid state. So yeah, I hope that answers the question about the vacuum tubes and about what you had to do to maintain a good signal.
What's this pattern here? There's an Indian on it. Is this the pattern?
I put it up. I don't know where it is. I'm terrible on Zoom. This is like my 4th Zoom meeting ever.
No,
And I'm not.
Good. It's very good.
I don't even see it on here. How do I get it up here?
I don't know, but it's there.
Yeah,
I put it on the share screen.
Yeah, it's visible right now.
Yeah.
Very visible.
I added the color bars and the grayscale.
Yeah.
It did not have that, but it's a very sharp. I can't see it myself, but I don't know how to get to the share screen.
Otherwise, it's the original pattern that would be.
Yeah, and because Chuck Farris bought it from somebody who had literally pulled it out of the trash. It had the cover sheet on it, like a translucent cover sheet on it. And somebody pulled it out of the trash and I guess auctioned it on eBay. He got a hold of it, cleaned it up, reproduced it and sold it for a while.
Yeah, this is not the original rendition of the Indian head as used by RCA back in '39.
Right.
How is it different?
Completely different illustration was used.
For the Indian.
Exactly.
And also, if you remember on the Monoscope, when it was fired up, the resolution lines were on the sides, top, bottom, and sides, not all compressed in that single circle. So it was substantially different.
Well, somebody has the copyright RCA on there, so maybe this was an earlier version of it. Oh, there. Gary's holding one
Chuck,
up.
Chuck pointed this out. Yeah, Chuck pointed this out. RCA never copyrighted the test pattern, never copyrighted the artwork. Chuck was very quick once he got possession of this to go ahead and get a copyright.
Yeah, this is actually the later version that was widely used for testing for many decades. And the thing I want to point out, if you look at the diagonal grayscale, you can see that it's actually made up of black and white lines. In the Indian head, where you see gray, that's actually a halftone gray that's not resolvable by the scanning beam.
What is Gary holding up?
It's NBC, backwards on my screen, but it's NBC RCA television system in the bottom. Can you hear me?
Yes.
Okay, thank you.
Is that original then?
Yes, that's original. Actually, I took it out of a television book. I can't remember which one right now, and then we blew it up to this size. And it was a test pattern shown in an early television book. I can't remember the title right now.
What purpose did the lines serve? You know, they're radiating out at 90-degree angles from each other. Why the lines? Was that having to do with the resolution?
At the bottom of the image?
No, they're radiating out from the center. They're regions of, looks like parallel lines.
Horizontal and vertical resolution. The narrower
yes.
the lines, the more it resolves.
Oh, got it. Okay.
Before they run into each other and you get a gray instead of a distinction between black and white. That is your limiting resolution of your system.
Okay.
What were the best black and white cameras capable of? Standard definition. What were they capable of in horizontal and vertical resolution?
Well, the vertical resolution, which is the horizontal lines, was limited by the number of scanning lines in the system. The horizontal resolution, which is the vertical lines in a studio camera, could be resolved all the way towards the center. But by the time you were bandwidth limited by the broadcast, the limit would be around 330 or so you would see the bottom vertical wedge, but the top one would be blurred. And then in a color TV with the chroma trap, the the finest part of the bottom wedge would also be blurred.
Yeah, I remember as a little kid, color broadcasts looked noticeably less sharp than black and white broadcasts in the late 50s.
Are you talking about on a black and white set or
Looking on a black and white set, yeah.
Yeah, they should have been the same, but if the camera had any misregistration, that would spoil the resolution to some degree.
Well, there was chroma crawl too.
Yeah, that was dot crawl. Yeah.
What's that?
Where you see these patterns in certain highly saturated colors along the edges.
Well,
Sometimes in the whole pattern, like a large red area. Red was always a problem on videotape and with color 3-tube image orthicon with a TK 40s and 41s. And recording on a videotape, you can notice today that with quadruplex recording, the banding on a red, I mean, you might have 4 different shades of red as you move up the screen, depending on the heads of the quadruplex recorder. Banding was a serious problem until 1-inch Type-C came along.
Why would that occur?
Because each head would be a little bit different in the videotape recorder.
Oh,
and if it wasn't properly tuned.
Again, again, it all depends on the operator who's operating the machine.
Right.
You did go through a setup if you had time. There was always color bars on a color tape at the head of the tape for a minute or so. And you did adjust head equalization before you played the program. So the heads were very close. Now there is an error called velocity error. When one head is going out, the other head is coming in, you're switching every 16 or so lines. And that was not a problem in monochrome, but it became very noticeable with color.
Right.
And this was one of the Ampex inventions. And of course, RCA came out with something very similar. Ampex called it velocity compensation to try to ameliorate this effect when one head is leaving, another head's coming in, taking over, making the program there, making the actual signal, so that the color phase stayed the same. But that was a bugaboo, and you know, especially in very saturated colors, you will see this velocity error there when you're switching from one head to the other. The 16, 17 lines of video each head is laying down with saturated colors. So the velocity comp generally did a very, very good job of correcting this, but it was not perfect. This was an analog system. You know, this was first generation, and you sort of took your lumps. It was kind of like the dog walking, you know, on its hind legs. You didn't marvel that it was done well. You marvel that it was done at all.
Right. What were the better videotape recorders? The quads, the RCAs, or the Ampexes?
I could not give an answer because it not so much the machine, what you saw on the air, it was a skill of the person setting the machine up, how well it was maintained. I couldn't say one machine was better than the other. I use mostly Ampex. I don't think there's any Ampex machine, quad machine, except the AVR3. I never use that machine, never maintained that one. But I started with the 1000s, of VR 1000s. I worked with 1200s. I worked with an 1100. I worked with 2000s, AVR 1s, AVR 2s, and they all made beautiful pictures. I'd go in an NBC facility where they were basically all RCA. And again, they looked very good too. So you just couldn't say RCA was better than Ampex. Ampex was better than RCA. They both made very nice pictures when the machines were set up properly. And it's sort of interesting, you know, how one company would come out with something, and 6 months, a year later, the other company would come out with their own version of it, like the velocity compensation. RCA called that, I believe, KVEC, and you had the Ampex, Amtech. RCA had the same sort of thing a little later. This was for making sure all the lines started at the same point on the left side of the screen, so you didn't have jaggies in the picture. Again, the on and on and on, just, you know, one innovation after the other, and that was good. There were two companies competing basically for the same market, because they were trying to come up with these innovations, trying to stay on top, trying to stay with something new, something that made the machine better, that people would want to abandon their old machine and come out and buy the next generation, the next model.
Just remember that RCA never sold a videotape recorder. because that term was trademarked by Ampex.
Ampex.
Yeah, RCA sold TV tape recorders.
Did RCA have to pay a licensing fee to Ampex since they had developed the technology originally?
I think they used PAL type workarounds, if you get what I mean.
I think what happened there was that RCA had a substantial amount of intellectual property in color television, and Ampex wanted that, and RCA wanted the basic patents on the machine. So I know there was a cross-licensing deal worked out,
yep,
which survived the entire series of machines. And I think that was, as Jim mentioned, that was to the benefit of all of us, because, as he said, there was a constant leapfrogging of technology between the two manufacturers. And over the years, you know, if we put an arrow into a calendar, we could say at that point, you know, company A had this and company R did not. But 6 months later, it'd be the opposite. So, you know, a tremendous amount of work was done. I've got quite a few of these machines, and the AVR1, AVR3, it's really hard to tell the playback from the original. A lot of the early artifacts from quadruplex format were completely cleaned up in the AVR1.
Is this 2-inch videotape? Is this 2-inch videotape with diagonal scanning?
Yes.
Are these? Oh, okay.
Yeah, if you look on
this,
the
2-inch quadruplex we're talking about.
Yeah, if you look at the participants that are on this Zoom call, TK41 girl has a picture up of an AVR1.
What is that?
Yeah, you have to remember when it came to color TV, RCA was the 800-pound gorilla of patents.
Right.
And so the way that other companies played the game is they developed all the patents they could, and when it came to the point where they had to license from RCA, the first thing they would do is put 2 stacks of patents side by side and reduce the number until RCA still had some left, and then they would negotiate what to license.
Yeah, going back to this cross licensing, Wayne, I did a story on the 50th anniversary of the showing of the first successful video machine, which was the Ampex, what became the VR1000 at the what was then the National Association of Radio and Television Broadcasters show, now NAB. This was in Chicago in 1956, and I had the privilege of speaking with 3 of the people on the 6-person design team for the original, Ampex video recording effort, and that was Charlie Anderson, who brought in the idea of using FM to modulate the signal on the tape. And the other person was Fred Fost, who actually made the first heads for the machine. And the other person was Ray Dolby, who was a very young person at the time. He was the junior member of the team. And of course, he brought a lot of innovation in too. But one of the things that came out of this, of course, RCA had been working on their own machine to record video. Bing Crosby Enterprises with Jack Mullen had been working on another approach. The BBC had their Vera, the Vision electronic recording apparatus. And so in RCA, of course, so you had these competing companies. And once RCA showed the machine there at the 1956 broadcaster show in Chicago, I know this RCA was big into color. They had planned their booth around color television, and it went nowhere because everybody was just blown away by the ability to record and play back instantaneously television signals. So Ampex certainly had the attention. Well, RCA, this is my story, RCA gave up completely their work on the machine they were working on to record video, and decided to get in bed with Ampex immediately. So yeah, there was a lot of sharing of technology between the two companies. Engineering teams from Ampex, which you've got to remember, basically at that time was an audio recording, instrumentation recording company. They sent a team to Camden, to RCA, and the Camden people sent their own engineering team out to Redwood City. And there was a lot of sharing of knowledge. And one of the things that came out, again, I knew engineers at both companies. One of the things that came out was told me by one of the older RCA engineers. He said it seemed like there was a lot about the recording machine that Ampex made, that the engineers at Ampex made and had perfected. They really didn't understand quite as well as we did here working in television, 100% of the time in Camden. So I thought that was an interesting statement. But again, you've got to look at what things were, where things were at this point in time. Ampex was again an audio instrumentation recording company, and not a video company. So yeah, there probably was a lot about video, or at least a certain number of things about video that the Ampex people were not, fully aware of, whereas the RCA people were. But yeah, there was a cross sharing of information that was immediately set up after that television radio show there in Chicago, NARTB.
Hey, Jim, didn't the BBC use some of the Vera research to do the standards conversions when the Telestar satellite did its first transmission from the US to Europe?
Not sure. I think at that time they were probably using just optical conversion, shooting a monitor with a television camera operating on whatever standard they wanted to put on the air. I don't think they were really using any of the Vera technology. John, go ahead. I'm sorry.
I was going to say, my understanding, having worked at AT&T for many years, is that they used a Bosch Fernseh converter that had an orthicon tube shooting a kinescope.
Yeah, it was strictly an optical conversion.
Yeah, and they were still using 405 line scan over there at the time.
Yeah, but what I'm thinking about
they've been.
Yeah, what I'm talking about is the difference between going at our 60 frames versus their 50 frames. You'd have a distinctive flicker.
They use, they use an orthicon tube facing a monitor, and I am sure that the phosphor of the monitor was very carefully chosen to avoid that.
Yeah, exactly. I mean, this is where this whole standards conversion thing started in Europe. I mean, the Brits were taking signals from France, Eurovision early on too, and just sticking a camera in front of a monitor. That was the first standards conversion. And electronic standards conversion didn't really get underway until the 1960s. I remember my first solid state, first real state-of-the-art conversion product. It was called the, let's see, John, help me here. I'm having a block. It was 2 racks.
Yeah,
and,
I remember.
It was Marconi, the dice, the digital intercontinental conversion equipment, dice.
Yep. I think it was a
And
half
it
a
was
million
TTL.
bucks.
I remember it had it 2 racks, and it had copper bus bars for the 5 volts for the TTL, and the copper bus bars were warm to the touch. This thing, drew so much current, but it did make a nice picture.
Yeah, that thing would convert 819 from France down to 405 too.
Yeah, it would go either way. That's what they call intercontinental, conversion equipment, dice. We're digressing. We're getting way off the monoscope here.
But it's interesting. Well, before we go, I'd be interested in the tape, that 2-inch tape. Didn't they get beat to death by those rotating heads? I mean, was the tape sort of disposable? How did they handle that?
No, they reused it all the time. A lot of the Johnny Carson Tonight shows got re-recorded on it or lost forever. NBC would reuse tape all the time.
Let me Now, there was a definite limitation on the number of passes you could make with 2-inch tape before it started to degrade, because the head is literally digging into the tape. It's making an indentation. The tape, with this vacuum guide, is being forced into the head. So there's a lot of friction there, and you have a lot of wear on that magnetic media. So the tape, I've seen tape that was played about 100 passes. It looks awful. You really never wanted to go anywhere near that before you discarded the tape. It did definitely have a useful life, which you did not want to exceed.
Okay.
We sort of, you really can't digress here. This, I think you can talk about anything you want. So if you want to keep talking about 2-inch tape or whatever, or if you have another topic, bring it up.
I'll bite. In these monochrome, the original Ampex 1000 or whatever it was, could they record composite color, which fooled the black and white TVs to extract the signal from the color, or was it a special adaptation to record color on 2-inch tape?
John, you want to take that one on?
Okay. Yeah. There were all kinds of cockamamie schemes that were produced. Most of them came out of RCA because they wanted to find a quick way to do it. They always had that pressure. So their color recovery originally was Heterodyne, where they would take the signal, they would record direct color on the tape, but then they would take the playback off it, and they would do a demod remod, which is the way that IVC did it in their VTRs later.
Yep.
Ampex decided that they were going to just do it on a direct basis, and after they had the InterSync servo and Amtech working, they built a device called ColorTech, which was able to reduce the time base error down to around 2 nanoseconds, which was good enough to eliminate hue shifting on playback. And then, as Jim mentioned earlier, the Velcomp came along right after that, which was absolutely necessary. And then they also discovered, oh, gee, we got chroma amplitude errors, which are causing some of the problems. So they built that into the system. And again, RCA did the chroma amplitude and Velcomp in one module, and Ampex did it separately.
Okay.
Yeah, let me throw this in, John. Just from day one, when Ampex made their first machine, the machines were recording color, but playing it back, that was a whole nother ball game, because the video coming off the tape, you've got a mechanical system, you've got a lot of perturbation. It was good enough jitter-wise there, perturbation-wise, to make a acceptable black and white picture. But again, because of the color signal, it could take a lot less of this. And to get color to lock up on a monitor, yeah, you really had to work at it. And you mentioned the Heterodyne System RCA had. Ampex had something called ColorCon. It was the same type of thing, a Heterodyne System, and they sold that commercially. I've seen that on some 2-inch machines during my travels, in various television facilities. But the ColorTech and RCA's version, the same thing, basically. To get this error down to an acceptable range, so you didn't have this incredible amount of color jitter. Yeah, you had to have that. Now, I'm gonna preface that with one remark. Again, this whole jitter thing, this whole mechanical perturbation, is caused by the spinning head and moving the tape longitudinally. If you had a perfect mechanical system, you would not need this correction, this compensation. And we went through heads, of course, 200 hours on a videotape head. That is a lot of wear. Most heads didn't make it to 200 hours. And you took the machine off, you put on another head, which had been refurbished, and sent the head off to have it refurbished for about $1,000. The price kept going up. What I was going to say about this, one night I was given the job of installing a newly refurbished head on an Ampex 1200 machine. And the machine had switch positions. You could see the video coming right off the demodulator before any processing was done, then off the Amtech, then off the ColorTech processing amplifier out of the machine with all the correction on it. And I'll never forget I put up a tape, I recorded color bars with this brand new head. I did some equalization. You have to do this when you're putting a new head in, and played it back. And I just happened to look at it at the demod output on the machine, the switcher position. And I had color locked up on the monitor. It just blew me away. This head was this perfect mechanically. There was so little error in it. I was able to actually lock up color bars without any correction, without any processing whatsoever. That was probably a once in a lifetime occurrence.
And my understanding is that on the first machines, they would ship the head assembly that made the recording with the tape for playback.
You're exactly right there. You're exactly right there. Yeah, Wayne, you're exactly right. A show was recorded in Hollywood, and of course the playback was in New York at the time. CBS, of course, started this, and then NBC, once the machine became reliable enough to put on the air, there was a lot of distrust. It was a new product. But once the network accepted this, it was good enough for network. It wasn't going to fail. They would record a show in Hollywood because each head had its own particular mechanical characteristics. They would take the head off the machine that recorded the tape and ship that back to New York for play out to the full network when it came time to play the show. You're exactly right there. This was before the correction devices, the Amtech and the ColorTech were invented and added to the machine to compensate for these individualities among heads.
Yeah, in 1965, when I visited the New York World's Fair and went through the RCA exhibit, they had a see yourself on color TV where the attendees got onto a turntable, went past the camera, saw themselves live, and then 10 seconds later saw a playback. And the way it was done is they had two 2-inch recorders side by side with a spool box for the tape to run through. So they were recording on one and playing back on the other. And that just blew me out of the water. I looked at that and said, boy, this really works.
Well, they use that same delay.
I'll add.
They use that same delay technique at KYW TV in Philadelphia for the Tom Snyder show. He used to have a call-in show, and you never knew what the callers were going to say. So they had the two recorders parked next to each other, string the tape up from one machine to the next, and that's how they create a 7-second delay.
Yeah, we did the same thing in New Haven at the station I worked for there. We did this live morning show dialing for dollars. And of course, the station did not want to air anything obscene or potentially slanderous. So they had the station management or engineering management had a box built to go between two machines to contain this loop of tape. And you would record on one of the machines, it would flow down into the box. There was what I'm trying to say, there was a device on the machine to stop the machine if it ran out of tape. We would tape that down and fool the machine to make it think it had a take-up reel on it. And it would go down in the box, come up and be fed into the head on the playback machine next to it about 10 seconds later. And the director producer of the show could go live if somebody said something that really was not broadcast worthy. And I'll never forget, this was Triangle Publications. They owned the station at that time. And the station was sold about 1.5 years into this to capital cities, communications cap cities. And they started budget cutting. And that was one of the first things that went, because think about it, you're wearing out tape and you're also wearing out two heads at the same time. And as I say, if you got 200 hours out of a head before it had to go back and be refurbished, that was a lot of use on a head. So again, you're putting a lot of time. It was an hour and a half show, as I recall. So at least 2-3 hours, composite there between the two heads per day. So it did add up. So one of the first things that the new company did was stop this and took the show live to air with no delay. And of course, within 2 weeks, somebody said something really off color on the air. Yeah, I remember having to take the tape, the SoundScriber tape, which was a very low fidelity audio track, which was recorded up the transmitter, and go back and listen and play this for management in case they had to do a legal defense to justify their license because somebody said something that was obscene on the air. But yeah, less than 2 weeks after they dropped this delay, somebody dropped a bomb on the a verbal bomb on the air.
Yeah, I talked about this with Merrill Weiss once, and he said that he put together a system, and I think this was much later with probably 1-inch tape, but he put together a similar system with 30 minutes delay by just jumbling the tape into a box between the two machines. And, with the right size dimensions of the box, the tape didn't knot itself up. It just kind of spaghetti back and forth and came out okay without ripping.
Is it possible to play 2-inch tapes anymore?
Yes.
Yeah, there are plenty of the machines around, but again, keeping them maintained, that's another thing. There are very few people that can maintain 2-inch machines. Now, John Turner can probably address this better than I. I did do some work for the Library of Congress at their audiovisual facility a number of years ago, and got 5 machines up and running for them. And there's still one company that refurbishes these heads. That's the big bugaboo. That's the critical thing. If you don't have a head, you don't have a videotape machine, quad or otherwise. So thank goodness there's still one company, and there's still enough demand that they can keep people, working, refurbishing these heads as they wear down, because this is a big wear item on a quad tape machine, 2-inch tape machine, is the video head.
Did they ever extend the life beyond 200 hours?
John, do you want to talk about RCA's AlphaCon 2?
Yeah, well, there's two things: the life of the head and the life of the tape.
Well, I mean the head. The heads on the machines.
Well, at the end of the era of the quad era, it was not unusual to get 1,500 hours on these heads. I've had a couple of them go well beyond that, and you pretty much take the head off the machine because you don't know what's going to happen. Because basically, as the heads wear, the RF output increases because you're reducing the inductance on the head, and you get more RF output into the preamp, and the picture actually gets better right up to the point when the head fails. But there's a couple of things here, as James mentioned. We had 2 head rebuilders in the U.S. One of them retired, and now we have one left on the West Coast. And I don't think they are doing RCA heads right now. They're only doing Ampex heads. And that's a problem because I got about a dozen RCA heads that I want to get fixed. But the use of these machines today is really for recovery of archival material. And there's 1 or 2 people who do this for a living, and they're very good at it. And then there's a couple of crazy people like myself that if somebody walks in the door and twists my elbow, I'll recover a tape of our AVR1. But electronics aren't the problem. Motors, blowers, the circuits. Fortunately for us, the circuitry in these machines at the very end was mostly DTL or TTL and discrete transistors, and they're all achievable or fine. They're not unobtainium, and that's the big problem. Is the heads are going to become unobtainium shortly.
The tapes made on the RCAs and the Ampexes, the 2-inch quad tapes, were fully interchangeable, weren't they?
Yeah, at the end, again, you know, we were talking about from 1956 to about 1980 or so, a period of time. And, you know, there was a huge variety of these machines in service and stations that, you know, in some cases were, you know, from the factory, and in other cases, the engineering staff, especially at the networks, was able to maintain these things and modernize them as kits came out from the factory. And that's part of the problem that we have in you know, getting some of these machines back online, is that there's mods that are in a lot of these that aren't documented, and that's a tough situation to try to solve.
The only real problem we had playing tapes back and forth, again, you had low band recording early on. Then Ampex came out with a much better head. They were able to move the FM carrier frequency higher up to provide a better picture. You didn't have a lot of the moire, a lot of the beat that you had with the carrier frequency down as close to video as the first generation machines. So you did have a high band, a low band standard. And the later machines, of course, could play both. But if you had a low band machine and somebody sent in a high band tape, don't care who made it, RCA or Ampex, you're not really going to play it so it looks like something you want to put on the air if your machine is strictly a low band machine.
And we also had an interim color thing called low band color, and it had better bandwidth than the original monochrome standard, but the color moire was horrendous, and that fortunately didn't last long. But the high band standard is from 7 to 10 megahertz, and that's substantially out of the area where harmonics of the baseband video would cause you any problems. It worked pretty good. And then at the very end, Ampex came out with in the AVR3 came out with a thing called Super High Band Pilot, which raised the frequency even further. Plus, it added a pilot carrier in the signal, and that machine in that mode, it's virtually, the output is virtually transparent.
For people who want to see
never
samples
forget, I
of
was
this
out
on YouTube,
I was
there-
out in
oh, go
Redwood
on.
City going to school on an AVR2, and they took my class back and showed us this machine. They were getting ready to show it in NAB, the AVR3. It was a brand new thing, still sort of in the lab. And they put a reel of tape up there with color bars, and I swear to God, I'd never seen color bars come off a videotape machine that looked that good. They looked like they were coming right out of the electronically generated bars right out of the color bar generator. It was just a beautiful system. But unfortunately, by the time they got this to market, not that many people were buying new quad machines. And then the next thing you know, you have Type C 1-inch, and that began to dilute the market even further for 2-inch machines. So Ampex did something really great with that pilot, that super high band AVR3, but it was a little bit late in the game to become a bestseller for Ampex.
I've got two of those, James, and I've done the interchange between them, and it's exactly, number one, the picture quality is as you say, and number two, the interchange was absolutely perfect. There was some industry scuttlebutt that RCA was going to bring out. I'm not sure whether they were going to bring out a TR600B or something like that, or a new quad that was also super high band, but it never happened. As you said, C format came out, and it was because it would give the people the ability to edit right on the tape in slow-mo. The quads went away real quick after that.
On YouTube,
Yeah,
there
that's
are
something you could not do with a quad machine. You could not do a slow-mo, fast motion. You couldn't do a freeze frame with a quad. It didn't work that way. So yeah, that's where the helical scan machines, such as the 1-inch Type C, were vastly superior if you wanted to do a slow-mo or fast, fast motion, accelerated motion, or do a freeze frame.
on YouTube, there are some very early tape recordings that have been restored and look pretty good. One is a Fred Astaire dance special from 1958 in color. There's an Etzel show from the late 50s, and then there's one with President Eisenhower turning on the color system at the Washington, D.C. NBC affiliate in the 50s. And they're all on YouTube. And you see how, what the
yeah,
quality of the cameras and the videotape was at that time.
Yeah, the one that WRC shot was restored by a couple of West Coast retirees in CBS Television City. And because it used one of those RCA heterodyne color variants, and they had to modify a machine. They modified an AVR1 to actually play that. The other stuff you're referring to was recovered by Dave Crosswaith, who's a good friend of mine out in Burbank, and he maintains 3 AVR1s, and I think Dave does the majority of the recoveries on 2-inch in the country.
That unit at CBS Television City is still in operation. I visited it last year before the COVID hit. And
Actually, yeah, I'm going to say, I was talking with Jay Ballard just this week, and he said, they took the last of the quad machines out of CBS Television City just recently. So that's kind of a rite of passage, I guess. Yeah.
Yeah, well, they're trying to sell that property because it's just absolutely
sold. It was sold a few years ago,
and they're just leasing back the facilities.
I got an email from a guy out in at CBS West Coast who told me that as of, I think, last week, there were no more quads in that building since 1956.
I'm curious, the magnetic tape, there was a lot of concern about audio tape simply degrading because the bonding may have failed or various reasons that the audio tape failed. Was this true of the 2-inch tape? Was that more robust, or have some of the images degraded due to the failure of the tape itself from aging?
A lot depends on how it's stored.
Yeah, I was going to say that this is interesting. As I mentioned, the way the tape looks is directly proportional to the number of passes the tape has had on playback. Each pass takes a little bit out of the tape. Again, I've seen tape with 100 passes. It really does not look like something you want to put on the air. If the tape has only been played once or twice, it looks pretty pristine. What I was going to say, though, the original tape had a shiny back. It was made by 3M, 379. If I'm wrong there, John, correct me. I believe the number is 379. And it had a brownish oxide and brownish orange oxide, a shiny back. And this was a standard videotape for many, many years. Then in the 70s, I think it was Ampex maybe started this, maybe it was 3M. They had this new idea for this backing, and it was a black backing. It was not shiny, it was rough. And this was going to be a quantum leap in videotape media technology. And I didn't really see that much advantage in it. And the problem came a few years later when people tried to play back these tapes on this new base tape. There was what was the number, John? Can you help me? 400 something. What was it called?
400 was the first.
John, you were there?
Yeah, I'm sorry. 400 was the tape you're referring to, and then they came out with 420. Then there was a later tape, which I think was 4250, which had dramatically improved audio. I don't know exactly what they did, because the audio was linear and the video was laid quad across the tape, arcuate style. So I don't know what happened, and I've never heard the difference in the tape, but 3M was selling that stuff as having a dramatically improved audio.
Yeah, where I was going though, this new improved tape with this rough backing, the tape layers began to stick together after it was stored for a few years. And it got to the point you could not play the tape audio or video. They did make audio tape with the same type backing. And a lot of stuff has been lost. You can get one playing out of this if you bake it at a certain temperature. Put it actually in an oven and heat it up below the Curie point of the magnetic domains on the oxide on the tape. You get one playing out of it, but otherwise the tape, the layers just stick to each other to the point the machine stops. It can't pull the tape anymore.
So it's a binder failure. Yeah. Okay.
Hate to interrupt for a second, but I'm going to leave you. Please continue your discussion as long as you want to. I think this will be open for as long as you want. So thank you all for attending, and I hope to see you next month.
Thank you.
Steve,
I
have you
need to
settled
bow
on a
out
date?
too. I've got to.
Excuse
Steve,
me?
have you settled a date yet for the next year's convention?
No, we haven't started working on that yet.
Yeah.
Probably the first weekend in May.
Okay.
Okay, good night, everybody.
All right.
Good night. Long, have a good one.
Bye-bye.
Yeah, I need to bow out too. I've got a ham radio
Yeah.
network early in the morning. I
Thanks,
need to
Ralph.
get to bed and get up in time for that.
Yeah. Oh, that was good. Thanks. That was really interesting. Thank you.
I wanted to share something about the Mike Douglas show. It came to Philadelphia from Cleveland in 1965, and it was a syndicated show done by Westinghouse Broadcasting. And it was done live on tape until Zsa Zsa Gabor called Maury Amsterdam a son of a bee on live TV, and after that they began taping it and putting it on a delay. But in order to distribute the program, it was sent on a certain number. I think they hit about 200 cities at its peak. They would record it on tape and only make about 12 tapes, and they would send them to a certain number of cities, the biggest cities first, and then they would mail those tapes on to the next city and the next. So people would be seeing the show as much as 8 to 10 weeks after it had been recorded, because the tapes were what they called bicycled after they were run. So the tapes got lots of play. Then they'd come back and re-record the programs over again on those same tapes and send them out and bicycle them all over again.
You know, it strikes me that the whole business of videotape technology is like the internal combustion engine in a way, because the basic principle is easy to understand, but then when all the little bits of physics come into it, you suddenly need more than a few pistons and an engine block.
I have a question if anybody could answer. I'm familiar with helical scan recording. I believe that's what consumer VCRs use. But before helical scan, how was videotaping done? Just a fast version of an audio recorder or something else?
No, that's what we've been talking about. That's what we call
Quadruplex.
Quadruplex. Basically, the machine that became the standard around the world spins the head across the surface of the tape from top to bottom with a very slight angle caused by the tape speed. There were 4 heads on a drum that was 2 inches in diameter, and lots of switching that allowed the appropriate head to be switched into the demodulator. So dramatically different than the helical scan machines that came later. And the big difference in the two technologies is simply, well, in one case, the first problem we had with helical scan was tracking. It was very hard to make the mechanics stable enough so that the playback machine, if it was not the same one that made the recording, would stay on the track where the video was. That was an amusing situation for many years. In fact, one of the first machines that was supposed to be used for the consumer, which was a Sony machine called a CV2000, in their literature, in their sales literature, in the very back of it, in 1 point type height, it said, "At this time, we cannot guarantee that tapes made on one machine will play back on any other." And a lot of people didn't read that.
Thank you.
Yeah, later.
The first
See?
video recorders ran very, very fast. So it consumed a great deal of tape, and they traveled ridiculously fast. And this was one of the systems that Bing Crosby had invested in, and it didn't work. And then they realized they had to get a rotating head to make up for the fact that you can't encode enough information at 7.5 or 15 inches per second. You make the head rotate, whether it's on a quadruplex head or a helical head. And that's the way it went. But he lost millions in that. And he had made a fortune on audio tape recording, which came from Germany as one of the spoils of war, as I understand it.
Yeah.
And he didn't want to have to do a show twice to sound good on both coasts. He only wanted to do it once. And he knew that the quality of audio tape, even in the late 40s, was indiscernible from a live broadcast. And he invested heavily on that, and he made money on that. And he saved his voice at the same time.
Does empirical scanning, is my understanding is a whole horizontal line is recorded in one scan. Is that right?
No, it's more like a one vertical scan. So that would be either a field or a frame, depending on whether it's interlaced or progressive.
That, you mean one swipe across the tape diagonally?
Yeah, and the advantage of that is that when that tape is put into playback and the tape is not physically moving, the scanner will pick up an entire frame or field of television, and you can edit from that.
Oh, so a whole field is recorded in one fell swoop.
That's right, and it depends on various machines. Some of them recorded a frame, some recorded a field. There were machines that had one head that scanned and it went around a drum and scanned an entire frame with one rotation around the drum at 3,600 RPM. And then you had other machines that had two heads and they scanned approximately 180, 190 degrees of the tape.
John, how fast did the quad machines run?
The original speed was 15 IPS, which survived to the end. There was a 7.5-inch standard that all the machines that I know of had, and that would allow you to double up on the amount of time you could record. But the video quality, of course, and the audio quality suffered quite a bit.
Yeah, like we know from Betamax and VHS tapes that the higher you ran the thing, the better the picture and the sound, until they got the hi-fi sound where they encoded the audio into the video somehow.
Yeah,
into the rotating head.
Yeah, that was done with like for example, High 8, Digital 8. A lot of them had PCM audio on them. We even have there's even a C format machine that has PCM audio on it. It was built by Sony. It's called a BVH 2180, and extremely rare, and it worked really well.
Yeah, John, you mentioned running the half speed 7.5 IPS on a quad machine. Yeah, you couldn't use a regular head on that. You had to have a special narrow head, otherwise the tracks run into each other. So you had to change the head out to make your slow speed recording, and the same thing with playing it back.
There's probably another reason why it didn't take off, because you had to pull out a 10 mil head and put in a 6 mil head, and those things were expensive. And I guess the station bean counters didn't want to keep an inventory of two different uncompatible heads.
What was the maximum length of a 2-inch quad tape?
I think 90 minutes, I think.
I mean, recording
90.
time or physical
Recording
length?
time.
90 minutes.
Okay.
90 minutes. Yeah, that's something too. Do you recall the exact weight of a 90-minute tape?
Heavy.
I know our smaller technicians had trouble actually lifting this and putting it up on the machine.
Especially if they were
They were
small.
not lightweight reels.
Probably over 25 pounds.
Yeah, it was a heavy thing, and we used to record Dick Cavett and delay Dick Cavett by I guess an hour and a half. We had something else we were running, and Cavett was an hour and a half there. It was our sign-off show, and one night I forgot to change out the take-up reel. I left a 60-minute take-up reel on the machine I started recording from ABC on. And I'm looking there, oh my God, well, you can't stop it. There's no way to do editing. There's no way to clean it up. What do we do? And I remember, praying to God that the machine had enough torque to go ahead and keep wrapping tape. Of course, it didn't spill the tape, but it did go outside the diameter of the 12-inch take-up reel. And it was not fun taking it off and putting, actually, I think what I did, I wound it back on I did wind back on the 90-minute reel, and you're darn sure I put up a 90-minute take-up reel and then on. Lesson learned, never repeated.
IVC made an industrial videotape machine that could take 3-hour reels. I don't remember the model number or anything, but it was an industrial machine from
It was a 900. IVC 900. Yeah.
Okay.
The problem was, of course, you couldn't play it on any other IVC machine, only on that particular model. And I've got a couple of them, and boy, I'll tell you, that is one, I don't know what to say here, one piece of junk.
Yeah.
The home helical recordings like VHS or beta also did a lot of interesting things with the system to allow them to tolerate looser mechanical tolerances. For example, they used heads that were wider than the spacing between tracks. And one head at the hub had its gap skewed a few degrees one way, and the other head had its gap skewed a few degrees the other way. So the tracks could overlap, but during playback, each head mainly saw the signal that had been recorded at the correct angle for it. And therefore, there could be some mechanical mistracking over the length of a field or a frame, and you would still get a usable signal because you had that extra guard margin that the tracking could wander.
People talk a lot about
that was so-called azimuth recording.
Right.
People talk a lot about deterioration of videotape over time, but I've got some VHS tapes and 3/4-inch pneumatics from the 80s, and they look okay. They play. I will rewind it before I'll play it and forward it and rewind it again generally. And they look fine. I mean, they look about the same as they did when they were made. They've been stored in mostly good conditions, occasionally in a garage or a storage facility, climate controlled storage facility. If you rent one of those, you know, it's really not so climate controlled. But it's amazing how well they've held up.
Well, I was going to say that back to the type of the tape base and the number of passes. Once I got the first machine up and running there at the Library of Congress, the quad machine, One of the things they wanted to transfer was a 1960 recording. I believe it was done in 1960, of course, on the 3M 379 tape stock. And it was a dedication of Channel 5, WTTG, their new facility in Washington. And it played back beautifully. And the next thing they brought in was a show recorded off PBS. I'm trying to think of the name of the show. It doesn't really matter, but it was on the rough backing tape. And we got about 20 seconds before the heads clogged. The machine just went ahead and stopped because it couldn't pull this tape that was stuck together. So, and that tape I know was done in the 1970s. So daylight and dark, it just depends on the tape stock, how well the tape was preserved, the number of passes. But I do know that 379, that original formula tape that 3M made for this recording done, I believe it was 1960, it played back beautifully. This was maybe 8-9 years ago. I did the work for Library of Congress, and they got to see the program and transfer it to digital.
Jim, why did 3M change the formulation of a tape they knew would work?
You know, who knows? You know, again, I'm not a physical chemist there. I have no idea what was going on at the plant there in St. Paul. Why they decided to move to this new formulation, and supposedly it had some advantages. John, I'd have to go back and look at some of the ads, some of the sales literature, but I know they touted some advantages for it. But I didn't. I used it. You know, we were kind of excited about it when we got our first shipment in there when I was working in New Haven, and I didn't really see that much improvement in the tape at all.
What are broadcast programs recorded on today? Are they recorded on some hard drives or SSDs or what?
Well, usually hard drives right now. Solid state drives are still, at this point in the curve, a little pricey, but they're certainly making progress. And within a few years, I'm sure everything in broadcast is going to be on solid state memory. But it's been that way for now, maybe 10 years. At stations.
Yeah, well, a lot of the camcorders, most of the camcorders, they're recording on solid state media, SD card right now.
Okay, James, what were you archiving things? James, were you archiving things at the Library of Congress?
Actually, my mission was to get some 2-inch quad machines up and running so they could do some archiving.
And what were they archiving to?
But I know the first machine I brought up, it was an Ampex 2000B, and that was one of the first things they wanted to do, the playback, this WTTG Channel 5 new facility dedication. So I do recall very vividly putting that tape up, and it did play back perfectly.
And what
but
were
I
they
didn't do the
saving it
archive.
to?
You know, I was just the guy working this one summer, getting some quad machines, you know, capable of playing back these tapes. They had something like 100,000 hours of 2-inch quad recording they had to transfer to digital. And of course, I don't think that is anywhere near completed, even after 7-8 years since I was out there.
And what are they going to? How are they archiving
Going to a hard drive.
The Library of Congress is using JPEG 2000.
JPEG 2000, yeah. Not MP4.
Oh, no. MP4 is lossy. JPEG 2000, if it's done right, is lossless, and you can recover the original material without any degradation at all. Of course, the penalty you pay for that is a great reduction in compression rate. You can do MP4 at 1/60th of the bandwidth of the video, and it looks okay, but you don't want to archive on that. But JPEG 2000 can be set to go anywhere from the sweet spot's basically 4 to 6 time reduction in bit rate, and it looks great. And that would be that's a good way to archive things. Now we have a new standard called JPEG XS, which is going to give us a further reduction, but nevertheless, they're not doing any intra-frame coding. All the coding is done on a single frame, and that's how you maintain the quality of the original.
How long has this JPEG 2000 been around?
Oh, gee, more than 10 years.
And it has no artifacts of its own?
Nope. We started using it in inner city long haul relay for AT&T. Oh, gee, 2000, 2002, sometime back that experimentally. And basically everything that comes through AT&T's television service today is JPEG 2000.
If you'd like to go back to the topic of sticky tape, my recollection is all in the audio field, and the same things applied to videotape. What James is calling the rough backing, I don't know if that correlated precisely with the change in binder. They are similar timing, but the thing that makes tape not play is hydroscopic binder.
Right.
And this came in some year or other in all the audio and videotapes. All of a sudden, they changed the formulation of the binder. And the story I've been told is that the previous binder contained sperm whale oil. That was banned, and they had to find a substitute. And what they found would work fairly well for several years. You could take a tape off the shelf 5 or 10 years later and it would play, but you go beyond the life, it absorbs water, whatever environment it is in, and it becomes sticky. And that's what makes the tape just come to a stop when it's in your tape player. It can be cured, as was mentioned, by heating it in an oven at about 125 for about half an hour. Now that's for a 1/4 inch audio tape. It's going to take longer for a 2-inch tape. But you get up to 125, get all the water out of it, it'll play just fine. You put it back in the storage condition, it'll reabsorb water and get sticky again. You can dry it out again. As much as you want to do that, you can play these tapes, but you have to be very careful. You don't want to get it above 125. That's the story that I know about sticky tapes, tapes that won't play. So your early tapes that will play, and I've got Scotch 111 that will play just fine, has a lubricant in it that doesn't stick.
I think that happened in the 70s. I'm pretty sure it happened in the 70s, the binder problem.
I can tell you, I can come within a year or so when I got my hands on the first new improved videotape. That was somewhere between 73 and 75.
Yeah.
So within a year or so, that's when we started seeing it in commercial television. But I was told, I don't know about the audio. I've not tried baking a tape, but I've read literature, at least with the video, and you have one bake. You can do one bake, and once you do that, you can't recover the tape again. I know there was an oven there at the Library of Congress, but they were very, very, very reluctant to bake a tape. They were looking for any other way of getting the information off the tape before they had to bake it, because again, the concern was once you did this heating treatment, you couldn't go back and do it again.
I don't know where that
I'm
story
not really
came
sure
from.
what the physical.
You can bake them again and again. You can also freeze them, and that'll take the moisture out. But it takes about 6 months in a freezer to move the moisture to the point it will play.
How long does it take at 125 degrees, David?
As I said, a 1/4 inch, 10.5 inch reel, 1/4 inch tape, about half an hour.
Half hour is all.
Now a 2-inch audio or videotape, obviously it's going to take, there's a lot more mass, it'll take longer. I don't have the number for that.
And typically audio tapes are on plastic reels that are open, mostly open, and videotape is generally on metal reels.
No, professional audio tape is on metal reels as well. Of course, you could remove the flanges if that concerned you.
So it's a pretty useful advice. Thank you for the advice, David. And another little advice that I can do is, well, if you want to store a tape for a long time, use a solid cover, such as a plastic cover, a metal cover, because, well, these paper covers are very good, but I don't know, it's pretty, mm, it's probably that the water get into the case and destroy the tape slowly, but only that. Be careful with that.
Just as a little bit of interesting news in the last few weeks, I attended a talk by an outfit that has discovered that on audio tape recordings that have excessive wow because of the tape stretching, they can, in many cases, recover the bias frequency and use that to correct the playback speed and cancel the wow in the old tapes.
Does that technology have a name, Wayne?
I can't think of the name of the company or the people who are doing it right now. I'm sorry.
If you go on the web and look up the Pacific Northwest Audio Engineering Society, they hosted the meeting last month that Wayne's talking about.
Thanks. I couldn't even remember who the host was. Another thing about the helical scan videotape is, as you know, if you have VHS and do fast forward or still, you get noise bands because the heads are crossing tracks. Because the tape is not moving at the normal speed. But in professional machines, they, of course, developed automatic tracking so that the heads would track no matter what the linear tape speed is. And you could do slow motion. And I think it was back in the late 80s, I visited the Wrigley Field where Trio Video was doing the remotes for WGN and toured the truck. And for the replays, they had helical videotape machines, and they just put a rubber doorstop on the reel, and the kind with a dimple in it, and the operator would just put his finger in the dimple and spin the tape reel, and the servos would all follow, and they had their frame by frame replay just like that. I see John nodding his head.
Well, that certainly was a lot easy. That's another reason why quads went away, because they could do that. But the other thing that the C format did was that it replaced the Ampex HS100, which was a hard drive, a 14-inch disc recorder that used quadruplex electronics to record and play, and it used stepper motors to advance 4 heads. They were great machines. They were very expensive. They were, I believe the unit was developed and partially paid for by Julie Barnathan at ABC. But they worked great when they worked. The problem they had was that for no good reason, the video heads would sometimes crash onto the disc and tear a groove in them. And those disc platters were about $5,000 each. So that was a scary thing because you never really knew during a sporting event whether you were going to lose the slow-mo or not. So when C format came along, number one, you had relatively inexpensive recorders. And number two, they worked great. They directly replaced that HS100, although it was a marvel of engineering.
I think I'm gonna wish everyone happy Thanksgiving and quit for the night. I'm out of topics, and unless somebody says, "Ooh, I got something," it'll be good night.
I like your background, Wayne.
Yeah,
That's a very cool background.
yeah, the CTC5 white elephant gets a holiday picture for Halloween, Thanksgiving, Christmas, and New Year's every year.
Hey, Wayne, don't you have a Zenith color set?
That's the one on the left. That's the aircraft carrier, and it's got an excellent rebuilt picture tube in it. But the last time I fired it up, which was several years ago, something had gone wrong, and the picture was flat white. And I just had taken the effort to turn it away from the wall and go ass and elbows into it to find out what happened. Oh, good night. Happy Thanksgiving.
Happy Thanksgiving.
You too, Wayne.
Take care, Wayne.
Thanks.
I think I'm going to run along as well. I got stuff to do tomorrow. So good night, everyone, and happy Thanksgiving.
All right, John.
Thanksgiving to you.
I'm signing out to Tom K from Columbus.
You ready to sign up?
Yeah, let's just wait a minute and see what happens.
Yeah.
Well, everybody, I think that I leave. I see you.